In this particular question, we have to determine the modulus and the principal argument of -4. So let us first rewrite our given value in the standard form. So that would be -4 plus I times 0. Now to find the modulus, so we have absolute value of z is equals to -4 squared plus 0 squared, which gives us 16 plus 0, which is equals to the square root of 16, and its value is +4. So here we have to consider a positive value for the modulus of z, because that represents the length of a complex number. Coming to the principal argument, first we have to find out the value of the acute angle alpha, which is equals to the tangent inverse of the absolute value of the imaginary part, which is 0, divided by the real part, which is -4. And this gives us tan inverse of 0, and tan inverse of 0 is equals to tan inverse of the tangent of 0 degrees, which is equals to 0. So the value of your acute angle alpha is equals to 0. But when we plot this complex number on the arctan plane, so we have -4 on the real axis, so we have -4, and the imaginary part is 0, so our complex number will be OA. So the complex number lies in the second quadrant. So since we are in the second quadrant, so our theta value will be equals to 180 minus alpha, and that gives us pi, which is 180 minus 0. So our theta value is going to be equals to pi. So this is the value of the argument of the complex number z. Let's move on to the next question. So here we have the complex number z given by 1 plus I. So we have to determine its modulus and the principal argument. So let us begin by first assuming that our complex number 1 plus I is given by z. We can say that z is equals to 1 plus I. Then the modulus of z will be simply equals to the square root of the real part, which is 1 squared, plus the imaginary part, which is 1 squared. And this will give us the square root of 1 plus 1, which is √2. So this will be the modulus value. Then we have to find out the principal argument. So before finding out the principal argument, which is theta, we'll figure out what's the value of alpha. So alpha value is going to be equals to tan inverse of the absolute value of imaginary part, which is 1, divided by the real part, which is 1. And that gives us tan inverse of 1. And we know the tangent inverse, tangent of 0 degrees, no, tangent of, which one is 45 degrees, that is pi by 4. The value is equals to 1. So we have alpha is equals to, so tan inverse of tan is going to cancel out each other. So we'll have alpha is equals to pi over 4. Now the argument of our complex number z, which is simply theta, is going to be equals to alpha, because our complex number 1 plus I lies in the first quadrant. So we can always check it out using our arctan plane. So we have the real part is equals to 1 and the imaginary part is equals to 1. So we have our complex number OA, and O and A has the point 1, 1. So we see that our complex number is in the first quadrant, so therefore theta is equals to alpha. So therefore the argument of our complex number will be equals to pi over 4. Let's move on to the next question. So we have the complex number 1 minus I. So let us consider that our complex number z is 1 minus I. So we have to find its modulus. So the modulus of our complex number z will be simply equals to the square root of our real part squared added to the square of the imaginary part, which is -1, and that will give us the square root of 2. So this will be our modulus. Now we'll find out the value of the acute angle alpha. So that will be equals to tangent inverse of the absolute value of the imaginary part, which is -1, divided by the real part, which is 1. So this gives us tangent inverse of 1. Likewise in the previous example, so alpha value is equals to 5/4. Let us now check it out in which quadrant the given complex number lies. So we have the imaginary axis and we have the real axis. So we see that our real part has the value of 1 and the imaginary part has the value of -1 here. So that means this is going to be our complex number OA, and A has the coordinate point 1, -1. So that means our complex number lies in the 4th quadrant. Now in order to find out the acute angle, so what we do is we have to drop a perpendicular, and a perpendicular is dropped from the point A on the real axis. It's always drawn on the real axis, it's not going to be drawn on the imaginary axis. That way we'll be able to find out the value of the acute angle alpha. Now clearly we see that our alpha is pi/4. This is an acute angle. Now in order to find out the value of theta, so we see that we are going in the clockwise fashion. So this itself is going to be theta, but since we are going in a clockwise fashion, it will be negative theta. So we have negative theta is equals to alpha, which is equals to pi/4, and that gives us theta is equals to negative alpha, or we can say it's negative alpha, or we can say it's negative pi/4. So this is going to be the argument, the principal argument of a complex number z, that is negative pi/4. Let us go to the next question. So in this question we have a complex number z given by square root of 3 plus I. So we'll find out the modulus. So we have the square root of the square of the real part added to the square of the imaginary part, and that gives us 3 plus 1, which is equals to the square root of 4, and square root of 4 is equals to positive 2. So we are neglecting here the -2 here because the modulus is always a positive number. Now we try to find out the principal argument. Before that we have to find out the acute angle alpha, which is given by the tangent inverse of the imaginary square root of 3. The imaginary part is 1 divided by the square root of 3. Now we have tangent inverse of the absolute value of 1/√3. So we know that 30 degrees, the 30 degrees, or we can say pi/6, the 10 pi/6 is equals to 1/√3, which is in turn gives us pi/6. So this is the value of alpha, since z lies in the 1st quadrant. So without even drawing our complex number on the arctan plane, we can say that our complex number z lies on the 1st quadrant because the real part is greater than 0, and so is the imaginary part, which is also greater than 0. So then in that case, the argument of the modulus is simply going to be equals to alpha. So we have 30 degrees, or pi/6. Let's move on to the next question. So in this question we have the complex number z given by 1 minus I over 1 plus I. So first let us try to convert it into our standard form. So for that we have to multiply the numerator and the denominator by the complex conjugate of the denominator, so which is 1 minus I. So that gives us 1 minus I whole square in the numerator divided by 1 squared minus I squared in the denominator. Let's expand the expression in the numerator, and that will give us 1 minus 2I plus I squared divided by 1 minus of minus 1, which is equals to 1 minus 2I minus 1 divided by 1 plus 1. So we have the 1 and negative 1 cancels out, so we have negative 2I in the numerator divided by 2. So that gives us z value to be equals to negative I, which can be written in the standard form as 0, since the real part is 0, plus I times negative 1. So we have in the standard form. So let us try to find out its modulus. So modulus of the complex number z is simply going to be equals to the square of the real part added to the square of the imaginary part. And we have 0 squared, which is 0, plus negative 1 squared, which is going to give us 1. So our modulus value is going to be equals to 1. Then we try to find out the acute angle alpha, which is tangent inverse of the absolute value of imaginary part divided by 0. Now we know that negative 1 divided by 0 is going to be undefined. So this case is only true when we have tangent of 90 degrees or pi over 2. So this is the situation when our tangent function blows up, or we can say it's undefined. So that gives us the alpha value to be equals to pi over 2. Now we'll have to check whether our given complex number lies in the second quadrant, third quadrant, or the fourth quadrant. So we have the real part of z is equals to 0. So this is neutral. So we can't say anything about this. But we have to go to the imaginary part, and we see that its value is negative 1. It's less than 0. So if we check this on our arctan plane, so we have 0, the real part is 0, whereas the imaginary part is negative 1. So negative 1 means that this is going to be our complex number. Let me redraw it. So this is our complex number. So we have O, and this is our A. So that means we have a complex number lying on the imaginary axis, and it's in the negative quadrant. So this is the case where we have found out the value of alpha. So our alpha value is this. This is going to be our alpha value. So that means our alpha value is going to be equals to negative theta, since we are measuring theta in the clockwise direction. So we have argument of our complex number z is equals to negative theta, which is equals to alpha. So that gives us the theta value is equals to negative alpha, which is negative pi over 2. So this is the argument of our complex number. Let's move on to the next question. So we have the complex number z here, which is given by 1 over 1 plus I. So let us first convert it into the standard form. So we take the conjugate of the denominator, which is 1 minus I, and multiply it to both the numerator and the denominator. And that should give us 1 minus I in the numerator. And in the denominator, we have 1 squared minus I squared, which is equals to 1 minus I divided by 1 squared. So minus of minus 1, since I squared is negative 1. So we have 1 squared plus 1 plus 1, which will give us 2 in the denominator. Now they're separating the real parts and the imaginary parts. So we have half plus I times negative half. So this is the complex number in the standard form. So the absolute value or the modulus of a complex number will be the square root of the square of the real part, which is half squared, added to the square of the imaginary part, which is negative half. So we have the half of square, the square of half will be 1/4, and the square of the negative half will also be 1/4. So that gives us 1/2, or we can say this value is simply 1 over the square root of 2. So this is the modulus value. Now we'll find out the acute angle alpha, which is equals to tangent inverse of the imaginary part, which is negative half, divided by the real part, which is positive half. So that gives us tangent inverse of -1, which is equals to the tangent inverse of simply 1. Now 1, we know that the tangent of pi by 4 is 1, so we're replacing 1 by tangent of pi by 4, so that the alpha value becomes equals to pi over 4. Now we have to check whether our complex number lies in the first, second, third, or the fourth quadrant. So clearly here we can see, so this is our alpha value. So we see that the real part of the complex number z is equals to half, and this is a positive number, whereas the real part, the imaginary part of our complex number z is equals to -half. So that is a number which is less than 0, so that means it lies in the negative side of our imaginary axis. So that means this is lying in the fourth quadrant. So we know that in the fourth quadrant of our arctan plane, the real part is positive and the imaginary part is negative. So that means we have theta value is equals to negative alpha, so which is equals to -pi over 4. So this is the argument. So our argument of our complex number z is simply equals to -pi over 4. Let's move on to the next question. So in this particular question, we have a complex number z given by 1 plus 2i divided by 1 minus 3i. So let us first convert it into our standard form. So we take the conjugate of the denominator, which is 1 minus 3i, 1 plus 3i, and multiply it to the denominator as well as the numerator. So that should give us 1 multiplied to 1 plus 3i. So we're multiplying the numerator plus 2i times 1 plus 3i divided by 1 squared minus 3i squared. On further simplification, we have 1 times 1 is 1, plus 1 times 3i is 3i, plus 2i times 1 is 2i, plus 2i times 3i will be 6i squared, divided by 1 minus 3i squared will be 9i squared. And that gives us 1 plus 5i minus 6, because I squared is -1, divided by 1 minus of 9 times -1, which gives us plus 9. So we have z is equals to 1 minus 6 is -5 plus 5i divided by 10. So let's write down in the standard form. So that gives us z is equals to -5 over 10 plus I times 5 over 10. We can simplify it, so this will be -half, the real part, plus the imaginary part, which is also half. Now that we have a complex number in the standard form, so let us find out the modulus or the absolute value, which is simply equals to the square of the real part, which is half squared, plus the square of the imaginary part, which is half squared. And that will give us 1 over 4 plus 1 over 4, which is simply equals to the square root of half, or we can say this is 1 over square root of 2. Now we'll find out the acute angle alpha, and that value is equals to tan inverse of the absolute value of the imaginary part, which is half, divided by the real part, which is negative half. So that gives us tangent inverse of -1, or simply tangent inverse of 1. So we have alpha is equals to tangent inverse of 1, and 1 can be rewritten as tan of pi over 4, because tan 45 degree is 1. So we have alpha is equals to pi over 4. Now we know that the real part of complex number z is equals to -half, so it's lesser than 0, whereas the imaginary part of a complex number is equals to half, and this value is greater than 0. So that means we are on the second quadrant. So we're the second quadrant. So that means second quadrant means the argument of our complex number z, which is going to be equals to theta, and the value is simply equals to 180 degrees minus alpha. So that gives us pi minus pi over 4, and the value will be equals to 3 pi over 4. So this is the principal argument of a given complex number. Let's move on to the next question. So here in this question we have the complex number z given by 1 minus 3i divided by 1 plus 2i. So we have to convert it into standard form. So we consider the complex conjugate of the denominator, which is 1 minus 2i, and multiply it to both the numerator and the denominator. So we have in the numerator so let's multiply it. So I'm going to straight away multiply it. So we have 1 minus 2i minus 3i plus 6i squared divided by 1 squared minus 4i squared, which is equals to 1 minus 5i minus 6. I have a minus 6 divided by 1 plus 4. So 1 minus 6 gives us a -5 minus 5i divided by 5. So our complex number z is equals to -1 plus I times -5 over 5 will be -1. Now let us find out the modulus, because we have the given complex number in the standard form. So we have absolute value of z is equals to the square root of -1 squared plus -1 squared, which is simply equals to the square root of 2. Now we see that the real part of our complex number z is -1, which is less than 0. Also the imaginary part of our complex number z is less than 0. So that means complex number z lies in the fourth quadrant. So that gives us alpha, which is equals to the tangent inverse of the imaginary part, which is -1, divided by the real part, which is also -1. So we have tangent inverse of 1, which is equals to the tangent inverse of the tan for 45 degree. So that gives us the acute angle alpha value as pi over 4. Now we know that since it's in the third quadrant, so our argument of a complex number z is going to be pi minus alpha, and we're going to measure it in the clockwise fashion. So we have a negative sign, so that gives us negative of pi minus pi by 4, which is equals to -3 pi over 4. So let's quickly check it out on the arctan plane, how we determine the value of the argument. So we have the arctan plane. So our real value is -1, and the imaginary value is also -1. So this is a complex number. A, OA is the complex number. That this complex number lies in the third quadrant. Now to find out the value of the acute angle alpha, so from point A, if we drop a perpendicular line to the real axis, that's what we always do. We always have to draw perpendicular to the real axis, and that will give us the value of alpha. Now theta, what we're going to do, we're going to measure theta in the clockwise fashion. So the value of theta will be in the clockwise fashion, starting from the positive direction of the x-axis. So this is negative theta. So that is negative theta. So in order to find out the value of theta, we subtract alpha, the alpha which is the acute angle, from 180 degrees. So this complete angle is 180 degrees. When you subtract alpha from it, we will be left with theta. Since we are measuring in the clockwise fashion, so we have to multiply it by a negative number. So that gives us the argument of the complex number, which is negative 3 pi over 4. Let's move on to the next question. So here in this question, we have the complex number z given by 1 plus 7i divided by 2 minus I whole squared. So first we are going to expand our denominator. So 2 squared will be 4 minus 2 times 2, which is 4, and 4 times I will give us 4i plus I squared. So that gives us 1 plus 7i divided by I squared is negative 1. So 4 minus 1 is going to give us 3. So we have 3 minus 4i in the denominator. Now in order to convert it into the standard form, so we multiply the numerator and the denominator by the complex conjugate of the denominator, which is simply 3 plus 4i. So let us do the simplification. So we multiply the complex numbers in the numerator by foiling it. So we have 3 plus 4i plus 21i plus 28i squared divided by 3 squared minus 4 squared I squared. So that gives us z value to be equals to 3 plus 7i, it's 4 plus 21, this is 25i minus 28, since I squared is negative 1, divided by 9 plus 16. So we have 3 minus of 28 is negative 25 plus 25i divided by 9 plus 16, which is 25. So that gives us the value of z in the standard form as negative 1 plus I. So now that we have the complex number reduced to its standard form, so we can find out the modulus, which is simply going to be equals to the square root of the square of the real part added to the square of the imaginary part, which is simply equals to the square root of 2. Now we have to find out the value of our argument of the complex number. So before that, we have to find out the acute angle alpha, that is the angle made by the complex number z, negative 1 plus I, with the x-axis or with the real axis. So we have tangent inverse of the absolute value of the imaginary part, which is 1, divided by the real part, which is negative 1. So that gives us tangent inverse of positive 1. So alpha is equals to tangent inverse of 10 pi by 4. So we have the acute angle is equals to pi over 4. So we see here that our complex number z lies in the second quadrant. That's because the real part of z is less than 0 because it's negative 1, whereas the imaginary part is positive 1, which is greater than 0. So that means our z lies in the first quadrant. So we have theta. So we have argument of a complex number z, which is equals to theta, can be determined by subtracting our acute angle alpha from pi. So we have pi minus pi over 4, which gives us 3 pi over 4.